Our next two speakers, Mahum Qadeer is an immersive technology applications engineer with a primary focus on technical art. Her expertise encompasses UI, UX development, 3D modeling, animation, UV texturing, and XR development. She earned her bachelor's degree in extended reality and game design from the University of Maryland. And for Nick, Nick Rowell serves as a communications strategist with a focus on all things space. From civil to national engineering security space missions, he acts as the portfolio lead, converting senior leadership intent into in communications efforts. He is an Air Force veteran with 12 years of experience in crisis communications, photojournalism, and strategic messaging. So please welcome Mahum and Nick.
Hi, I'm Mahum. I'm part of the XRCC team, and I'm also an immersive technology applications engineer, and my main focus is like technical art. But for this one, this was actually my first project by the time I joined APL. And I think we worked on it for about a month and a half over a period of time. And it was really fun, it was really engaging, and I did it with the help of Nick Rao and Blake and a few other people as well.
Yeah, so first project, we gave her 2 months to say, you have to get this done for the time we need to get it to a conference. And so the idea is taking the technical expert and the squishy communications guy and putting it together into a way to take the storytelling that is needed with the technology that's available to deliver a product that's going to make the impact that we want. So why did we choose Cislunar? So the problem is that Cislunar is extremely hard to visualize. It's this idea of a massive amount of space. So like every good story, let me give you some background. So first, Cislunar is all of the space outside of the geosynchronous belt. Geosynchronous is about 22,000 miles from Earth. So you think 10 times the amount of that is what Cislunar is, and it goes in every direction. And so to understand the size, scope, and scale is just one aspect of that. But the community also needed to be able to understand how everything interacts in that area. And so you need speed, you need placement, you need the understanding of satellites, where the moon is, where the Lagrange points are, these little gravity situations, little gravity wells that act as kind of the guideposts or the map of what Cislunar is. Because Cislunar is constantly rotating. The Earth is spinning, the moon is spinning around the Earth, that whole system spinning around the sun. And if we were to put somebody in a headset and have everything spinning, it'd be the last time we ever did that demonstration for somebody. And so we had to create a kind of a static version, and those Lagrange points help us set that up. And so what we had noticed was that everybody had been seeing Cislunar wrong in the past. So if you were to see Cislunar, you would see it much like Penn State had done here, with the Earth and the moon, and here's some different trajectories going along the Cislunar corridor. But in realistic view, Cislunar, from here to geo would be one slide, and then 10 times, or 10 more slides to the back of the room, you would finally see the moon. You can't represent that in any way that makes people understand how complicated the situation is. Plus, you can't show it in 3D. Things in space don't move in a two-dimensional plane. They move in 3 dimensions. And so when they were seeing it, even the White House presented it in this like secondary view, which is where they've added gravity and other pieces. But if you look, there's 2 little dots. One is the ISS, and it's just about touching Earth. And the other is that ring around Earth, and that's geo. So everything outside of that is Cislunar. That's the whole thing. And the reason it is so important is because we are not the only ones who want to do Cislunar. China has gone to the moon. There are national security aspects. There are other commercializations that want to do the moon. So people understanding this in the best way possible is something we wanted to get people to understand. And as we lead LSIC, which is the Lunar Surface Innovation Consortium for NASA, and the Lunar Operating Guidelines for DARPA, we have a drive in the community to bring people to come and talk about these things. So the idea is we had to create a story that everyone could kind of latch onto, but we had to present it in a way that they could understand. Which led us to what was our best option for using that. And a lot of times we're running into people who are in the community, who are decision makers. We're running into them at conferences. We're running them at large-scale events. We're giving demos when they come to senior leader engagement things. You don't have a great opportunity to put somebody in a VR headset and say, hey, you've got 10 minutes, let's walk you through this. No, we need something that can go on and off very easily, then give a situational understanding of what that is, and then being able to move from person to person or do multiple people at the same time seeing the same thing. So it was a lot easier to do that in this scenario. Plus, a lot of these people that we were connecting with work in areas that have highly classified assets in space. And so we wanted to prove, so we did this intentionally with Wi-Fi off and Wi-Fi disabled, to be able to show them that this capability existed and that they could take it into their scenarios and load their content into it, which was a huge sell for a lot of the 3 later agencies that are interested in cislunar space, which is a huge piece of it. But I think there was a lot of technical aspects to it as well.
So I think another big reason we picked HoloLens is also because when you're introducing this type of, I guess, demo at a conference, you also need to understand there's a generation, like a generational gap when it comes to exposing somebody into technology such as this one. So for instance, it would have been probably a lot easier if we just put it in VR, but then you would not understand the scope and scale of what Cislunar actually looks like. It kind of just makes you disconnected with your real world environment. So then that's why we picked HoloLens, because if you're 60, if you're 50, or if you're 4, you can put it on easily and you can take it off easily. I put it on my mom and I put it on my 4-year-old nephew, and I think they were both equally as engaged, and I think that was really important. And I think in other demos that we've done in the past that were in like the Quest Pro or these types of things, people don't want to get into it because they're uncomfortable with the technology. You put controllers in somebody's hands, they also can't see. I think a big aspect of that is also with HoloLens, you can just touch it versus like your real space. And another aspect is that the Quest 3 at the time, it had, I believe, just come out or was about to come out. Their video pass-through wasn't very good as either, so that's why we opted for HoloLens. And so this kind of leads into our approach. And this was a drawing, or designer, artist for this was Mike Yakovlev. I said that right? But basically, this is where we're showing here is there's a person outside the cislunar space, but essentially when they put on the headset, they are involved in the cislunar space. So then you truly understand the relationship of yourself and actually the scope of how massive Cislunar truly is. Because if you put yourself in a blank screen, you don't really understand how big something is, versus if I can look over somewhere over there, there's the moon, over there's the Earth. That's a big sense of distance from where I'm standing right here. You can also understand, visualize, if you're seeing something in real time, the scale of and the speed of the satellites, how many satellites there are, how crowded that space actually is, or how big that space actually is.
Yeah, and we wanted to go with a storyboard approach to this. So you create a script first. The idea of like what we're going to say, what we want the audience to see, and what we want them to take away. But most importantly, what we want them to feel when they're in this. They want to come out of this inspired, so that they can have their own ideas of like, oh, I have my problem set. I want to put my problem set in there. We're not selling you a solution. We're giving you an idea and something to put your imagination against. And that's something that was really important. So when we started our approach, we had a couple things in mind. We said, one, I would think it would have to be intricate but not exquisite. This idea of like, it needs to be accurate. So it had to have accurate data put into it, which is real orbits. So we took all the open source unclassified orbits, and we made a cut, and we put those in there. The reason we did that is because we wanted to make it available to as many people as possible. The second is we wanted to have it at the right scale at what it was. So when they put the Earth and the Moon, and they built that sandbox that people would kind of stand in as part of this experience, it was built in a way that it was relative to itself. So if something was this far from Geo, it was this far from the moon. Like all of that was accurate. So the speed and the pace at what things were moving was the next piece we wanted to add. So what we did was we set it to 15 minutes for the period of 1 month. And so then what we did was made sure that each day would then move at that time rate. So somebody who was doing astrodynamics or somebody who was doing space domain awareness could see the real thing that they had saw and go, oh, I watched that one happen. And that led to the next part, which was we picked a real event that we wanted to have in there. So that was the Artemis 1 launch. And so as part of the Artemis 1 launch, they had multiple pieces that went into Cislunar. And Artemis is the mission that's going to be putting astronauts back on the moon the Artemis 3 mission. So we wanted to have a real point. So we picked November 2022, and we did that entire month so that they could see it, including some of the unique orbits that they had been talked about in the papers about what was going to be done and how they were going to do it.
I think another really interesting point to point out is that there's 16 satellites going through this entire Cislunar demo, and there's, I think, about 4 or 5 different countries that we included as well. All of this is open source data, and I would say within the Excel file, there's probably like millions and millions of lines of coordinates points of the time and the entire space that these satellites are moving. And so it was a little intimidating at first, but with our help with the rest of the XRSCC team, we were able to get a data reader in Unity and as well as a CCV file reader. And all of that in Unity in real time was able to like go through the data, store it into an item we call a scriptable object, which is essentially a pre-stored reader, if you would call it, into a file. So when we play it on play, it starts immediately, which is also a sense of optimization as well. So this was on the right. You can see there's a, I think that was the Excel sheet we got from Wayne.
Schley.
Yeah, and so that was how it was supposed to look, and this is what we were known. This was like our base point. And so eventually it ended up looking like that, which was, I think, pretty cool. All of them were different colors, and we use this thing called a trail renderer. So the trail renderer is actually a render of the past 3 days, the timeline of the last, 72 hours. Not the entire timeline it was going through Cislunar. So it would eventually disappear and it would show that certain timeline. And on the left there, you can see that there's Artemis 1, Artemis 2. Those are the ones that circulate around the moon. And this is a great way to kind of visualize our data. And so then when if you do try our demo after this, you will understand the spatial understanding of the relationship to everything. And you will kind of see how every single satellite moves and how different their trajectories are. And one thing I think that it also kind of leads into why we chose HoloLens is because this is a lot more engaging than simply just watching a video. Or, for instance, listening to this PowerPoint. You actually have a story to tell when you leave this space, and you're just understand it. It's more engaging, and you can just take it off and walk away, and there's no hiccup around that whatsoever. So that was pretty cool. And this is our demo. Go ahead.
Yeah, and so what we do is we start people at the moon. We want to give them a point. So the moon is the static point inside the demo. So wherever they start, we always put them on the moon first. And then as they look down to their left, they're going to see the Earth. But to get to the Earth, you have to walk 4 or 5 steps. You have to engage your body to get over there. So as they walk up to it, they're going, oh my God, this is huge. And they look and they see these trails and they're like, oh wow, if that's how far it's going in 3 days, I can understand how fast it is moving in that environment. And they can also see the types of orbits. One of the things about Cislunar that's different than the regular kind of orbits inside of GEO is that in Cislunar, things move like spaghetti. They are all over the place. You have an orbit that is not elliptical. You have it start in one area, come back across itself, and move all over the place. They do this for, 1, whatever they're trying to achieve with their mission, and 2, to maintain the best fuel and efficiency out there in Cislunar space. And so for those who are worried about space domain awareness, this is an incredibly hard problem to track something that doesn't move normally. And so when they can see all the things that are going on, they go, oh my God, I need a solution. I have a problem and I need somebody to help me solve that. Which leads to the people who are showing them the demo. The ones who are like, oh, if you can present this to us into a way that we can understand it, you obviously have an understanding of the Cislunar challenge. Here's my problem. Here's what I've come to. So that opens up kind of the next ways of like what to do with this, right? It's one thing to educate and inform, but the next piece of it is to what do we want the audience to do with it once they have it? First, hopefully they had a great experience and they're going, okay, something clicked in my head and here's my problem. And they want to use it in their solution. And so we've seen people who've come up to us and said, I want this for training. I have space warfighters who are going to be on the console working this real mission, and I want them to see what Cislunar looks like before they get into it. Can I buy your headsets right now? No, you cannot buy our headsets, though maybe if you made us a great offer, that might change my mind. But the idea is like they want it immediately. The second one was said, I want it for exercise planning. I've seen the environment you've created. Can I put my data into it? And then can I remove things from it to figure out how difficult it would be if I lost a sensor, if I couldn't do something from Earth? If I couldn't understand or see the problem completely, what would that be like and how would my people interact to it? And then lastly is to present it to decision makers so that they can make informed, educated decisions on what Cislunar is. A lot of the times the Cislunar decision makers are getting something that says, believe me, this is how it's going to be. Or they're seeing things in SDK data, which is like a single two-dimensional view. We had somebody from the National Security Council come up and he was viewing it and he goes, wow, I just had a briefing and I wish I had this. I wish I could have shown it to the people in that room because then they could understand what he was talking about. You immediately put it on and go, I get it. That's the whole point of telling the story. The idea is like taking that idea, fusing it with the technology that brings it to life to be able to deliver the impact that we're going for and what the audience needs.
Cool. Questions?
And you can try it out too, so we've got it over in the thing. Put it on, take a couple minutes, walk through it. You can be a fly on the wall in space. It's the only time you'll survive out there without a spacesuit.
All right, thank you, Mahum and Nick. All right, folks, we're going to take a short break for about 10 minutes. We have a little time, so feel free to talk amongst yourselves for a bit. Green light, you're hot. Red light, you're on. Hey, everybody. Just in case we had some additional questions from the previous presentation, the Cislunar presentation, Nick here is willing to answer a couple of questions that we can record here. So if you would like, please go ahead and ask away.
Yeah, I jumped off a little too early, and then people came up afterwards. So if there are any additional questions, feel free to ask them now. So one of them I got was, why did we choose the background we chose with it? And so it originally was in just like a, hey, you could see through everything type of piece. But when you're in space, what does your brain say you're supposed to see? Black, starry skies. Yes, exactly. So we added that, and that changed so much. People were now like, oh, I'm here. I'm immersed. I'm in it. It's just the little things of understanding what the audience is going to want or what the audience is going to expect, and then building that into the process. I believe there was one also about the choice of Cheichao, which was one of the Chinese satellites that are up there, and the orbit that it was in, because it's not currently in the same orbit. So one of the reasons that you see it the way it is now is because that was what it looked like in 2022 in November. There are some of those that aren't even up there. Those Artemis ones, they crashed into the moon. It was intentional. That's how they got rid of them. And so like, this was a snapshot in time that you could see that piece. So while things now have changed into different orbits, this is kind of what it looked like then, and that's what that gives. And so if somebody wanted to add their piece into it, or they wanted their most current data, you could provide a catalog. The thing is, Mahum has created the kind of sandbox to put it all into, and that's what we're going for with this. Others. Last chance. Okay.
Have you thought of it up to a more powerful, like mission analysis tool, such as GMAT or something, which can do, like, if I fire the thrusters here for this long, it change the orbit this way, things like that?
Yes, we've actually thought about that and realized that it would probably need more than what we have here. So we have an ArmorX system in SES that was built under an IRAD piece, which is starting to build pieces of those. So we said, here's the idea that we thought of. What can you do with it? Because they run it off of a much different system, more powerful. They're doing things for the Army right now that is kind of doing that. But yes, the idea of mission planning was something that we got asked for from people from NASA. They said, hey, think about this from a mission planning standpoint and see if you can integrate some of these things into it. So yes, we have been thinking about it, but it would need a significantly more powerful aspect to run all of those on it. All right.